Hello everyone, this is Theo and today we are gonna have a look at problem set 4, question 5. There are two springs in the system with lengths of L0 and are in their equilibrium states. There is a point in the middle between the two springs. We need to find the work done required to move the point vertically by a distance of x. After that, we need to find the first non-vanishing term of the binomial expansion of the work done when x is much smaller than L0. Firstly, we may let the length of the springs after the movement be L, which we may use Pythagoras theorem to find that it is equal to the square root of L0 squared plus x squared. Then, the extensions of the springs are just equal to the square root of L0 squared plus x squared minus L0. We can calculate the potential energy stored in the springs to be 1/2 times k times delta L squared times 2. Expanding out the square, we have this formula. Since there are no non-conservative forces in this system, the work done on the system is simply its change in potential energy plus its change in kinetic energy. The springs are in equilibrium position initially, so the change in potential energy is the potential energy we calculated earlier. There are no moving parts in the system in its initial and final state, so the change in kinetic energy is equal to 0. Therefore, the work done on the system is simply the potential energy we stored in the springs. For B part, we know the binomial expansion of the square root of 1 plus t. To expand the square root of L0 squared plus x squared, we may first factor out the L0 from the square root, and let x over L0 squared be t. Substituting into the binomial expansion, we get that negative 2 L0 times the square root of L0 squared plus x squared is equal to negative 2 times L0 squared minus x squared plus 1/4 times x to the 4th over L0 squared plus other higher degree terms. Putting the expansion back into our formula for work done, the two L0 squared plus x squared parts cancel out, and we get that the work done is equal to k over 4 times x to the 4th over L0 squared plus other higher degree terms. The higher degree terms are negligible, given that x is much smaller than L0, and we have found our solution to part B. This is the end of this question. Thank you for listening.